In the last class, we began the discussion on important points in a triangle, the points of concurrency of various important lines in a triangle. So if three lines pass through a same point, it is called as, the lines are called as concurrent lines, and the point through which they pass is called as the point of concurrency. So first point that we discussed was centroid. Centroid is a point of concurrency of the medians of a triangle. Medians are lines that join the vertices to the midpoints of the opposite side. So centroid is the intersection of the medians, and the centroid divides the median in the ratio of 2:1. So this is an important result. Next, we will discuss the in-center of the triangle. What is an in-center? Any of you know what is an in-center? Centroid and in-center. Now, in-center is the point of concurrency or point of intersection of the point of concurrency of the angular bisectors of a triangle. Point of concurrency of the angular bisectors of a triangle. And so let us do that. Let's take a triangle. Suppose here it's an isosceles triangle. I'll take another triangle. Now, this is A, B, C. Okay. Now, I'm drawing just by observation, it is not by calculation, but I'm drawing. See, if I make this like this, it is not an angular bisector because the left side angle is smaller than the right side angle after division of this line. So if I make like this, again, it is not an angular bisector. So I am drawing an angular bisector with angular bisector of A. Okay, this is the angular bisector of A. Then we'll have to draw the angular bisector of B. This angular bisector of B, and this one is the angular bisector of C. So this point, the point of concurrence of the angular bisectors is the in-center. This is A by 2. This angle is A by 2. This angle is B by 2. B by 2. C by 2. C by 2. So now in-center has a property that from in-center as the with I as the center of a circle and radius as one of the radius as the distance, the perpendicular distance from I to one of the sides, you can draw a circle, and that circle will touch that circle will touch the three sides of the triangle. Okay, this circle is called as the incircle. This is the incircle of radius denoted as small r, and I is the in-center. Now, how to find the coordinates of the in-center? Now, there is a how to find it. There is an important principle. Now, let us say the length of the side BC is A. Length of the side BC is small a. That means the side opposite to vertex A is small a. The side opposite to vertex B is small b. And the side opposite to vertex C is small c. Okay, this means the side BC is equal to A, all right, CA equal to B, and AB is equal to C. So let this be the sides. Now, in center, this angular bisector has a property. Okay, what is the property? That the angular bisector of an angle in a triangle divides the opposite side in the ratio of the adjacent sides. In the ratio of the adjacent sides. So angular bisector of any angle in a triangle divides the opposite side in the ratio of the adjacent sides. So let us look at these points. That where does angular bisector hit here, cut here at D, here it cuts at E, here it cuts at F. So now, if that is so from here, BD is to DC is equal to C is to B. Is it not? Based on this property. How does this property come by, these are two equal angles, one common side. So based on similarity principle, you can do it. Okay. So two equal angles, both the triangle have, and then one adjacent common side, and one more property. So by that, it is not exactly similar triangles, but we can prove geometrically. So BD is to DC will be same as C is to B. BD is to DC is same as C is to B. So this angular bisector A divides the join of BC in the ratio of C is to B. Similarly, we will get this point E. All right, so based on that, we get the point D, and we also get the point E. So we can say that CE is to EA is equal to A is to C. A is to C. Then let's take the third one. The opposite side is AF is to AF is to FB is equal to AF. B is to A. So from here we can find out this. From this we can get D as. So now let us say A is x1 comma y1. Here let A have the coordinates x1 comma y1, B have the coordinates x2 comma y2, and C have the coordinates x3 comma y3. Okay, so now B and D get divided in the ratio C is to B. So D point B, therefore D is, see this is x2 comma y2, this is x3 comma y3. So mx2 plus n x1 by m plus n, that formula, section formula when we apply. So here in this case, we will get this. Now this is B, sorry, C is to B. C is to B. So C times x3 plus B times x2 by B plus C, comma C times y3 plus B times y2 by B plus C. This will be D. So now we don't have to go up to E. Now I have to find I. Now let us look at this triangle now. ABD. Now in triangle ABD, what is the length of BD? BD length, it is C is to B, right? So C by B plus C times the total length. The ratio is C upon B plus C. Total length is A. So BD length by ratio and proportion. What I've done here is ratio and proportion. Total length is A. This is C is to B. So what is the length? BD length will be C upon B, the total length B plus C times A. Is this clear to you? Both of you? This step? Yes or no?
Once more, can you explain?
Yes. So BD is to CD is to DC is C is to B. So let us say so BD by DC is equal to C by B. Now let us say there is a proportionality constant. That means BD is actually K times C. DC is also K times B. Okay. Actual length BD is K times C. DC will be K times B because where K is the proportionality constant. Okay, this is a side point I'm doing. So now BD plus DC will be equal to A, the actual length. So K times C plus K times B is equal to A. So from there we get K is equal to A upon B plus C. Therefore, BD will be K times C. So A upon B plus C times C. That is what I did directly. I didn't go through this. It is just a ratio proportion. All right. Total length is A. The ratio is C is to B. So the proportion, the fractional length of BD will be C upon B plus C times the total length. So fraction of this is C upon B plus C of the length of it. So that is how we get. So we get AC by B plus C. That is the length BD. Now let us go now in this triangle ABD. We know the coordinates D, we know the coordinates A. Now DI, now the angular bisector of B in triangle ABD, the angular bisector of B divides this DA divides DA in the ratio of the sides. This DA will be divided as BD is to BA. That is, what is BD? AC by B plus C is to BA is C. So common factor you can turn out. So you can write this, which is same as A is to B plus C, because it's a ratio proportion. So AC by B plus C divided by C will be A by B plus C. So A is to B plus C. So now, so DA is divided in the ratio A is to B plus C. So DI will be A is to IA will be B plus C. DI is to IA is equal to A is to B plus C. Now what is the coordinates of D we found here? Coordinates of D. B2x2 bx2 plus cx3 by B plus C. by2 plus cy3 by B plus C. Okay. And what is A? x1 comma 1. So dA is divided by I in the ratio of A is to B plus C. So I will be M is to N, right? M times x2. So here x2 is x1 comma y1. So what we get is a times x1 plus b plus c times bx2 plus cx3 by b plus c divided by a plus b plus c. Then we have for this term a times y1 plus b plus c times by2 plus by3 by b plus c, a plus b plus c. Okay, this gives I is equal to, now b plus c cancels. Then we straight away have ax1 plus bx2 plus cx3 by a plus b plus c, ay1 plus by2 plus cy3 by a plus b plus c. I could have given you the formula directly for you to memorize, but I wanted to do it because you will get a feel of how these are derived, and these are not difficult. It is purely derived from section formula. Centroid is derived from section formula. In center is derived from section formula. So now let us observe the triangle here. I will draw the triangle again here so that we understand this. A, B, C. This is say in center I. Opposite to vertex A, the length of the side is small a. Opposite to vertex B, the length of the side is small b. Opposite to vertex C, the length of the side is small c. And the coordinates of A, B, and C are x1, y1, x2, y2, and x3, y3. Okay. Now, what is the in-center coordinates? You see here. With x1, what you have to multiply? The length of the opposite side. So A x1 plus B x2, again the coordinate with the opposite side length, plus C x3 divided by A plus B plus C, sum of all the sides. So this is the in-center. So that is the x coordinate of the in-center. Same we use for the y coordinate of the in-center. So it is the point of intersection of all the angular bisectors of the triangle. So this is denoted by I. Now we can have angular bisectors for exterior angles of a triangle. So we have the three x centers. Okay. I'll try to demonstrate. So let us take a random triangle. 1, 2. So this is a triangle. See here, opposite sides A, B, C already written, and sides A, B, and C are already computed. Now I'll draw angular bisectors. So angular bisectors of sides, this side and this side. So there are two angular bisectors. Okay, we'll show what these are. This is the internal bisector of the internal angle. And then when you extend this side here, this line bisects the exterior angle. And when you extend this BA also further, so this line bisects that exterior angle. Now let us look at the angular bisector of angle B, AB and BC. You get this is another angular bisector. Bisector of the internal angle and the bisector of the exterior angle. Next, let us do the bisector of angle C. So interesting, right? So we have got so many points of conflict. 1, 2, 3. This point is the incenter. Okay. So this point D is the incenter. Okay. Now I'll draw a circle. Okay. Or of course in radius. So this is the incircle. Right, I'm plotting it in red color. It is incircle. This is the incircle, and this is the incenter. Now, these are the X centers. X center opposite to A. Yeah. This is X center opposite to A. So let this point be, this is F. Now, there is this X center. Just a second. Okay, this is the incircle. Next, for X circle, from F as the center, we draw another circle. Now you see okay. Now you see it is touching this side, but you are not sure whether it is touching the other side. It will touch the other side. In fact, if I draw a line passing through A and C, You see, this is touching this other side. Okay, right now, what I'll do, I will only plot the in center. I'll remove others. I'll take other diagonals. Okay, so there's the in center. Now, what I want to show is the X centers. Now, similarly, the X centers opposite to A, I'll directly write this. This is external division, but we can write this. The X center opposite to vertex A is I1. That opposite to A is the side small a, right? So replace that with minus sign in this equation for in center. In this expression for in center, replace A by minus A. Ax1 minus Ax1 plus Bx2 plus Cx3 by minus A plus B plus C, then minus Ay1 plus By2 plus Cy3 by minus A plus B plus C. This is in X center opposite to A. Then the X center opposite to vertex B. So here we see opposite to vertex B is this X center. Opposite to vertex A is this X center. Okay. So center opposite to vertex B, X center opposite to vertex B is I2. We will just replace B by minus B in the in center formula. So we have Ax1 minus Bx2 plus Cx3 by A minus B plus C. Ay1 minus By2 plus Cy3 by A minus B plus C. And the X center opposite to vertex C is I3. Ax1 plus Bx2 minus Cx3 by A plus B minus C. Ay1 plus By2 minus Cy3 by A plus B plus C. A plus B minus C. So if you remember the in center formula, you will get the X center formula. And this comes by simply using the external division section formula. Okay, internal division I showed, external divisions I'm not sure. So actually X center is the point of intersection of one internal bisector and two external bisectors. So I will show, I will replace this AC with a line segment. You just here, point A, point C. So line AC. I will draw pink color lines of the sides of the triangle. line AB. And then line AC. So many lines, huh? So just so I drew the triangle, extended the triangle lines. ABC is a triangle, but AC I have extended the line and pink line, so that it will be easier for us to understand. So what is an exterior? What is excenter? Point of concurrence of one internal angle bisector and two external angle bisectors. So this one point F here is the bisector. This line is the internal angle bisector of A. But here we see this is the exterior angle. This is the angle B, and this is the exterior angle B. This line is the external angle or exterior angle bisector of B. And this line is the exterior angle bisector of C. So one interior angle bisector or internal angle bisector and two external angle bisectors. So point of concurrence of this is the excenter. Similarly, this point here is the point of concurrence of this internal bisector and the two external angle bisectors at ANC. So this is how this happens. So excenters. So in problems, we should be cautious of how we solve the problems. Next, what is orthocenter? Orthocenter. Does any of you know what is an orthocenter?
Yes, sir.
Yes, what is this?
The point of intersection of the altitudes of a triangle.
Very good. The point of intersection of the altitudes of a triangle is the orthocenter. So let us say this is A, B, C. Okay. Now the altitude is the length of the perpendicular line which is perpendicular to BC. Line which is perpendicular to BC. That is the altitude. AB is the altitude. Then and then so D, E, F. So D, E, and F are called as the feet of the perpendiculars from the vertices to the opposite sides of the triangle. So D, E, F are the feet of the perpendiculars. So they are feet of the altitudes of the triangle. This intersect at a point. This point is called as the orthocenter O. Okay. Now, there is a formula for orthocenter. Immediately, you will not be able to do it. It requires understanding of the properties of a triangle, trigonometric properties of a triangle. But for sake of completion, I'll just write here what is the orthocenter coordinates. When we do properties of triangle, that time combining with properties of triangle, we can show this. Here also we can show, just like tan. If we know basic trigonometry, what is tan, opposite side by adjacent side, from that you can get orthocenter coordinates O will be x1 tan A plus x2 tan B plus x3 tan C by tan A plus tan B plus tan C, comma y1 tan A plus y2 tan B plus y3 tan C by tan A plus tan B plus tan C. Now this formula is seldom used for intermediate level problems. It is useful for IIT JEE type of problems. We can avoid this formula also by straight line equations. We can find the orthocenter. So it is orthocenter is the point of intersection of the altitudes, of the point of concurrency of the altitudes of a triangle. Okay. Next. So centroid, incenter, excenters, orthocenter, one more very important is the circumcenter. Circumcenter. What is the circumcenter? Circumcenter we denote by S. Orthocenter by O, circumcenter by S. It is the point of intersection, or point of concurrence of the perpendicular bisectors of the sides of a triangle. Okay, now let us try this. I'll erase everything. Now let us take again the similar triangle what we took. Now let us look at the perpendicular bisector of BC is this line, perpendicular bisector of CA is this line, perpendicular bisector of AB is this line. This is the circumcenter. So this point is the circle. Here we are denoting by D. If we want, we can change the name also. We denote by S. Okay. Now, interesting. Now I join. I'll draw a circle with S as the center, with one of the vertices as the radius. I can draw a circle, and this circle passes through all the points. So this circle passes through all the vertices of a triangle. This is called as the circumcircle. This is called as the circumcenter. So we get this for in-center and circumcenter. That for in-center there will be a circle touching all the sides of a triangle internally, and for x-centers there will be circles touching all the sides externally. And for circumcenter, it is a circle. Circumcircle is a circle passing through the vertices of the triangle. So circumcenter is, again, this is beyond your proof right now. At this stage, I cannot do this proof for you. You will have to understand the trigonometry sufficiently, but I'm just giving the formula for completion here. X sine 2a plus x1 sine 2a plus x2 sine 2b plus x3 sine 2c plus sine 2a plus sine 2b plus sine 2c. Okay. A very important result, which is recalled again and again and again, many times. A very important result is the centroid G divides the join of circumcenter and orthocenter in the ratio 1:2 internally. Very, very important result. Now, how to remember this? Centroid is dividing. Centroid will be in the center. Center means in between point. C, circumcenter comes first, orthocenter comes O. O comes after C. 1 comes after 2. So remember that way. Centroid divides the circumcenter, the join of circumcenter and orthocenter in the ratio 1:2. Okay. After C is O, after 1:2. So that way we can remember the join of circumcenter to orthocenter in the ratio 1:2. So all the basic results for introduction of coordinate systems is over. Let us do some problems. Let me just check. I'll just share with you. Yeah, I'll give some problems. Yes. Thank you. Okay, I'll not waste much time. I'll just give some very simple problems. Uh, in your textbook, there are no problems given. That's why I'm just searching. Hmm. Okay, let's do this. I'm sharing screen. I will do some typical problem, one problem today and another problem in the next class. So let us start with this one. Okay, this is question one. One end of a thin straight elastic string is fixed at 4:2 or 4 comma minus 1. And the other end is at 1 comma 2 in the unstretched condition. If the string is stretched to triple its length, find the new position of P. So X, Y. Now, point A is 4 comma minus 1. So 1, 2, 3, 4 comma minus 1. This is point A. And B, what is the point B is 1 comma 2. So 1 comma 1 comma 2. This is the point B. Now this is the original length or the original distance. Okay. Now let us say we extend it. So I'll draw purposely with another color. Now suppose I extend this line. That means triple its length. Length is L. Now the total length will be 3 times the original length. So let's say this is the new point B dash. This is the elastic string. So it is originally situated at A2, and from B it is pulled to, at A it is fixed, and B it is pulled to B dash. So what are the coordinates of B dash? So let's say B dash is H comma K. Okay. Let, I'll write here after drawing this figure. Let the new position of the point B be B dash H comma K. Now the total length is 3. So AB will be 1, and this part will be, this will be 2 parts, because total length is 3. Because now AB dash is 3 times AB. Therefore, AB is to BB dash is equal to 1 is to 2. 1 part is to 2 parts. So, therefore, we can say B divides B 1 comma 2 divides A 4 comma minus 1 and B dash H comma K in the ratio 1 is to 2. Therefore, 1 comma 2 B divides now M1 X2, that is 1 into H, plus M2 X1, that is 2 into 4, by 1 plus 2. Then 1 into K, plus 2 into minus 1. M1 X2 plus M1 Y2 plus M2 Y1. So we have H plus 8 upon 3 and K minus 2 upon 3. So equating the X coordinate and Y coordinates, this implies 1 is equal to H plus 8 comma 3. 2 coordinates are equal means their individual components will be equal. So Y coordinate will be equal to K minus 2 upon. From here we get H is equal to 3 minus 8, which is minus 5, and K is 6 plus 2, 3 into 2, 6 plus 2, 8. Therefore, B dash minus 5 comma 8 is the new position. So, what is this problem? This problem apparently looked a verbal problem, but it is simply a problem on section formula. We have used formula of internal division, but we can do the same thing with the formula of external division, because B dash divides the join of AB and AB in the ratio. This is AB dash is to BB dash, that is 3 is to 2 externally, and then we can calculate and you will get the result. Directly you will get H comma K. All right, I'll stop here. Was this clear?
Yes, sir.
Tomorrow onwards, we will start, in the next class onwards, we will start locus, and in locus, we will do problems. All right, I will stop here.